Hello everyone, welcome to Nrcm. This is Shravani and I am going to explain about operating system of Unit 4 and the topic is segmentation. Let's moving on to the slide. Like, what is segmentation? Segmentation is memory management technique. So it is a memory management technique in which each job is divided into several segments. Here you can see the job is divided into several segments of different sizes, like one for each module that contains pieces that perform related functions here. So and here each this segment will be performing different functions, and here each segment is actually a different logical address space. It contains this contains different logical address space with here, like every segment will contains different logical address spaces of the program. So when the process is to be executed, its corresponding segmentations they are loaded into non-contiguous memory, though even every segment is loaded into a contiguous block. It is loaded into a contiguous block of available memory. So segmentation memory management, it works very similar to paging, but here segments are of variable length where the paging is of fixed length. So you can see like the segments are of variable length and size. Okay, and the program segment contains the program's function. So consider if like the segment can be having like different, like if it is a subroutine, means it will be containing its subroutine functions. If the segment is of stack, it will be containing the stack information. If it is symbol table, it will be containing the information of this symbol table and so on. So like just like the base table or TLB, for segmentation, all the information necessary, whichever is necessary, is stored into the segment table. Okay, everything will be stored in the segment table as shown in the diagram. So this is the segment table. And the relationship between the logical and physical address is a bit more complex here. So little bit of common differences there. Like here it involves the segment table, okay, and base address, and next is it will be having the limit address and the segmentation number as well as the offset. So the segment table is like what it contains. The segment table. Here the correlation and mapping for the logical address with the two-dimensional address and the physical address is done with the help of this segment table. So I'm just repeating again. So here mapping for the logical address, which is two-dimensional address, and physical address is done. Okay, mapping is done here with the help of this segment table. That is segment table. Next is base address. As we all know that the starting address of the memory where the data is stored in its logical format is in the system is called as the base address. So like if the base address is like somewhat around 800, then the data will be available in the address from 800 onwards. You can say like starting address. And next the limit. As we have discussed here, this limit indicates like if the size of each segment is different. Thus, each segment has its own limit defined, and it tells the system about the size or length of any particular segment. So, this limit will indicate the size of each segment is different, even though if it is different. So, here each segment will be divided into, it will be giving some limited access. So, within this base and the limit address only, you will be getting the we will be getting the files which are available. Okay, and this limit address should be always lesser than it should be lesser than, else some error will be thrown here. And so I hope you understood. Like since the size of each segment is different, each segment has its own limit defined, and it tells the system about the size or length of any particular segment. So and further we can see, like you can see here in the diagram, what is S and what is D. Like S is nothing but it is segment number. It is a segment number. It is basically a total number of bits that are required to store any particular address of the segment in the consideration. And offset as well, like it is number of bits required for the size of the segment. So this is about segmentation, and next we are going to the example of segmentation. Here you can see the example of segmentation. So the program, it has been divided into different segments, and it is having the different logical address spaces. So your memory management scheme that supports user view of the memory, like as we all know that a program is a collection of segments. A segment here segment is a logical unit, like such as here we have main program, procedural function. I think you can see here. So here it is the main program and the different types of stack tables, and here this all segment, it contains the main program and some procedural functions and some methods. Okay, different types of methods, and it contains different types of objects. Okay, and next it contains some local variables and global variables, and it will contain stack, symbol tables, and some arrays also. Okay, so this is the user view, you can see. As you can see, like for each segment, so for segment 0, 1, 2, 3, 4, so 1, 2, 3, 4, there is starting address, that is base address, as well as the limit address. So you can see here, so segment 0, here 0 is present in between, like, so starting address is 1400 and the limit is between 1400 plus 1000. So the limit is this one. Up to this segment 0 can be, within this the segment 0 will be found. And next, coming to the like segment 1, so segment 1 is present here, and the limit is like to 6700. This segment can be found, this segment can be found here, and so on. Okay, I hope you all understood this example. And the next, moving to the segmentation with paging. So actually this segmented pages is the implementation of segmentation, and here the segmentation and paging, they are combined. So firstly the process, they are divided into different segments here. Okay, as you can see, the process are divided into different segments. As a process, they are divided into different segments, and after that we divide each segment into multiple pages. See, if you see here, each segment will be divided into multiple pages. So these segments are divided into different pages, and for each segment there is a page table. Okay, so this is the segment. For each segment there is a different page table. So here also found for each segment we'll be having the different page table, and this page table that stores the information about the frames. Okay, about the frames. And so as you can see here, it contains frame is equal to, so it contains information about the frames. And here virtual address contains 3 parts. What is virtual address? This is the virtual address, and it contains 3 parts. So first is like a segment. So first indicates this is the segment number, and the second is the, so segment number is nothing but it is a segment, the number of the segment. And next is page number, it specifies which page number. And the next most important is like page offset, so indicates like how many words are, the page contains how many words. So you can see segment number, page number, and then offset. Okay, offset will be there. So here segmented paging undoubtedly solves the problem of external fragmentation. Okay, that is the advantage of this, but the disadvantage is like it suffers from internal fragmentation. So this is all about like segmentation with paging. So, and here with the help of this, and we have found that, so there is a page. Okay, and thank you, and I will be coming up with the next video.